thanks for being here. It's kind of late on the second day, right? So you never know if there's going to be even one person in here. So yeah, thank you very much for turning up. Yeah, we'll be talking a bit about toning some chaos into some privileges and trying how we've been doing some experiments with LLMs and other things as part of our red teaming. So hopefully it should be interesting. Do let us know as well if we speak either too slowly or too fast. We have some very different presenting styles, and I tend to talk way too fast. So just put your hand up if I'm doing that. So yeah. But we'll be running through like a few things, right? The attacker's lifecycle, and then quick introduction to some of the AI stuff, and then go through directly into the use cases of how we've been using the LLMs for basically making our own life as red teamers a bit easier, and likewise how we might see if there's any differences that has changed because of using the LLMs for the red teaming. So yeah. Quick intro, I guess. Jay Christensen, I run the Mandiant red team for EMEA. I know we kind of oversee a lot of the capability development as well that we do in region, and then share that with the rest of the global red team. Like mountain biking, game development, and traveling. So that's me. Quick intro.
Yeah, so my name is Matthijs Schiele. I'm based in the Netherlands and I'm part of Jay's team. In my spare time, I mostly do some snowboarding and reading and a lot of board gaming.
Yeah, so we're sort of pretty traditional nerds, basically, right? A lot of writing code and a lot of them trying to kill ourselves in our spare time.
Yeah,
yeah.
more or less.
But yeah, we work in what we call at Mandiant, ironically, APT66, right? We wanted to give ourselves our own cool code name, but we didn't want to interfere with the numbering system. So we call it APT66, and it was basically because we wanted to distinguish and make a group that only tried to do advanced red teaming and capability development to try and move away from pen testing per se and go more into sort of adversarial emulation stuff. So we do a lot of R&D and a lot of like whenever something weird new comes up, we'll try and test it and break it and see how we can mess with it, right? So our mission statement is basically we try to emulate what we see from the threat actors, but also try and take it a little bit beyond. So if they're doing something, we want to do something 5% cooler or 5% more evil and see how we can get away with it. And in this case, what we wanted to do with, everyone's talking about AI, and not surprisingly when we work at Google, right, there's AI everywhere. So we're like, how can we use this to automate some of our work or make it more advanced, or in some way at least have some idea about, will this even affect red teaming? Will this affect threat actor capabilities in some way? So instead of researching it from after the fact that it's happened, we thought we'd go and make some of these capabilities. So yeah, that's basically the background to this whole thing. And yeah, this presentation will just be some of those examples, some of those different things that we've kind of been working on innovating. We have future plans as well, right? But this one is to just go through and see where in the attacker lifecycle so far does it actually make sense for us to throw in some LLM usage, and where does it not make sense also a little bit. And then give some quick defender tips and takeaways. So if you're more from the defensive side, wanted to also assure you that the world isn't ending, basically. Attacker lifecycle, pretty sure most people know this, but this is just what we'll be, just to make sure we're all on the same page. Red team attacker lifecycle, right? Initial compromise, get in, drop some persistence, move through the systems, take them over, complete your mission, whatever it is, right? Steal some important stuff or some money or something else, right? Really mess with things. But this is where we kind of take our approach from. It's like where along this path it makes sense to actually try and innovate. And obviously we can continuously make malware, we can continuously make new tools, but in this particular case, we wanted to see if there's any abilities for the LLMs to make it even better. Yeah.
Yes, so I'm gonna talk a little bit about large language models. Most of you probably already have heard of some. For example, ChatGPT is a very famous one. And it's basically a statistical language model which will generate and translate text. In simpler terms, what it does is it is a program that will predict the next words on some input. And it's usually very verbose. So if you type something into ChatGPT or whatever, you can get like very long text and stuff like that. But we wanted to use it for more getting structured data out. So we want to process natural text and get some sort of fixed type of data out. So there are a lot of libraries to process output of LLMs, and they're usually called guardrails. And in our examples, I will show you some code examples, we will be using the Guardrails AI library. There are quite a lot of other ones that are also built into ChatGPT and that kind of stuff. And in this case, we're going to use some Python models. And here you will see an example of a model you can use. And what you want out of of the LLM is basically represented by a class. In this case, the class is the pet, and what you want to get out of it is a pet type and a name. So this is to process output. And now you're going to use that in combination with guardrails, and this example uses OpenAI, but you can use it with almost any LLM. And you basically give it some sort of prompts, and then you put in some magic prefixes, and you basically build the whole prompt from the pet class. Now, basically, what does it look like if you actually print the output? You basically have the prompt on top, and then the library will generate a very big blob of text telling the LLM how to output the data. And you can see that it will process it, and it will just give you the output saying pet type is dog, name is Buddy. So you ask the LLM, like, give me a pet name and what type of pet it is. And in the end, you just get out like pet type is dog, name is Buddy in your Python script. Why is this useful? So let's go over some scenarios where we're going to show you how we use this approach and what we got out of it, and why it is nice. So going to talk about a couple sub-parts of our tech lifecycle, the initial reconnaissance, initial compromise, and then a couple of other steps. So the initial reconnaissance. Our goal for this was get a target for initial access into an organization. More simply said, we want to have targets for phishing, basically. And what we think is the LLM has a large context window and a lot of data parsed from the internet, and it might help us to select targets for phishing, basically. So normally what we do is we scrape social media sites, and we get like the names and roles of people of our targets. So basically you go, for example, LinkedIn or other places, and you type in Mandiant, give me everybody who says they work at Mandiant, or in this case, who works at Chaos Hospitals, and we try to guess the email format. If you have some examples online, like if you can find some examples of email addresses on the website, for example, their marketing manager or something, you can usually figure out what their email address is. So what we have is the name, the role, and the email address, usually. Who to target? So if you have 30 targets, it's very easy. You just go over the list and you just select some nice targets of people you think are most vulnerable to phishing. But our clients are usually very big companies, so you can have like 10,000 or maybe 100,000 people. And how do you process that a bit faster? So what we in Threat Actors often select for if we want to target phishing is not IT people, and especially not cybersecurity people, because that is a very quick way of getting burned. So if you send a message to the SOC directly, usually they will figure out it's phishing. We want people that are relatively new in their role and don't have a lot of experience in the company, because then you don't know what the normal procedure is in the company. So if you don't know, like if you're very long in the company and you know we don't get random emails giving you goodies or giving you iPhones, then it's usually harder to phish. And lastly, we like it if people are open to getting emails from strangers. This is, for example, recruitment, legal, but also sales, like more or less internet-facing, so outward-facing people are usually best to target because they're more likely to actually read your email and do anything with it. A lot of IT people don't like answering emails, so they just ignore whatever you send. So, using an LLM for role analysis. So I just typed, in this case, to Gemini, like, hi, can you please indicate if the next role is related to IT? So I basically just asked the LLM, hey, if I have a title called Director of Chaos Hospitals, can you please indicate, like, if it is IT or cybersecurity related, and estimate how experienced this people is, or like how high the role is in the organization. So Gemini will give you a nice answer saying IT says cybersecurity is no, experience level is 8, and then gives you a whole explanation of stuff. Well, this is not, if I run this over my entire database, then I still have to go through all the outputs to sort it. I just want a table basically, and then just sort by experience level and no cybersecurity experience, please. So first try, please give machine readable output in JSON. You get some nice JSON output, but the fields are sort of semi-random. So if you run this multiple times, you get like random fields. So if we think back to the library, we just make a nice role output saying like the role, IT, nice flags. And then you basically see that you get quite a nice output. Even though we're not in sales and marketing, we still like Excel sheets sometimes. So you can see if I have some roles, it will gladly indicate for me if it's IT, cybersecurity, and what the experience level is. So if we now look at in what order we should fish people, we should, according to Gemini at least, we should start with the physical therapy intern and then go to the human resources generalist and then basically that way. And see that the IT person is basically one of the last people to fish based on this. So we can of course do this for 7 people, but for 100,000 people this is way faster. You can, even though there might be some false positives, you still go through the list way faster than I can do myself basically. I think this is your
yeah, so the other aspect of obviously getting initial access is not just the people, right? But because of the processing the information very fast, that means that if you get a lot of that input that is a bit semi-random, things like Shodan, things like Nmap scans, whatever you can find lying around, if you, like me, don't have time to read or can't read anymore, right, then you can basically get this thing to actually just come up and suggest and say which of these targets is actually best. And it doesn't do that on any kind of like strong reasoning. You basically just have to explain what you find to be best. So you will say things like servers that are running unpatched vulnerabilities. And because it's consumed large amount of CV information as well, it can quite often come up with pretty good suggestions to say which boxes should you start looking at. Some of the organizations we work will have 100,000 exposed endpoints, right? And you have no way you will have enough time to go through and manually check this sort of stuff, review every single page. But if you feed it a shitload of, sorry, I'm not allowed to swear. If you feed it loads of screenshots of the sites, then you can go through and say which of these sites are actually login prompts. What's open login prompts of all this information without you sitting there scrolling through, I don't know how many, like what's it called, like some of the like Go Witness and some of these programs, print out loads of screenshots of all the sites and you have to manually check through. The LLMs and some of the other models can actually go in and say, well, this is a screenshot of a login prompt, and because even try and give it more information, oh, it looks like Tomcat. And it will actually come up with this information much quicker than what we would do manually. And if you had to try and do this in the olden days, like a couple of weeks ago, then you would try and grep for string information, right? But it's very hard to write a really good grep query that would give you the same stuff. This reasoning that you get out of the LLM seems to be a lot better at picking out kind of fairly interesting targets that also you might not necessarily have considered. But that is because, again, it's ingested all the GitHub stuff, it's ingested all the CV libraries, and it ingested your information that you give it. So it also allows you to kind of fairly quickly correlate stuff. You can say, like, is any of these version numbers matching a known weakness, which essentially, I guess, eliminates most of what Nessus does, right? It's the same matching of like version output to actually say, well, there's an exploit that exists for this, and you can ask it to only suggest stuff where there is an exploit that suggests. Most of the stuff we do is still phishing based because there's organizations that are fairly mature, so it's not often for this, but especially the stuff of doing things like password spraying and finding all the prompts very quick has been very helpful in this sense. Is it on me? Oh, yeah, quick defenses. Basically, we're going to have this for each section, but basically, just do it yourself, right? If you are the guy running the organizational defenses, try and do some of these things and make sure that you have tried to do this recon yourself, because you will be surprised at some of the odd servers that are still out there, or some of the people that have posted on their LinkedIn profile, yeah, I'm an expert in so-and-so defensive software. And then it gives a lot of tips to the attackers. I also did run an interesting one where I tried to use the LinkedIn thing on my boss, and it somehow, through the paywall, picked out his entire work history. So I'm not really sure how the LLM has ingested LinkedIn, but it might actually go through that bit that you need a connection. So it got some information that you would only have if you were his direct friend. I'm not 100% sure how it did that, but that definitely made it an even more advanced recon tool against the people. So they has clamped down a little bit on it. Now it says I can't give you information about a person, but that's only the bigger language models. If you've got your own trained one, for one of the smaller ones, they can still be used for some of these things. The initial compromise afterwards, right? We want to gain access to the target organization, and we're hoping that this can help us create some of the stuff that we need to, the artifacts we need to make. That's our hypothesis, right? Can it emulate human responses a bit better than some terrible scripting? The answer is yes, right? So phishing is one of the more common things that you have seen LLMs being used for, I think, already. And we also kind of use it for this because it's very good in the creation of emails. One of the common things that you get knocked out in the old days on phishing emails is the fact that you would write the exact same email to 100 people. So they could simply just go, why did we get 100 emails from this account? This seems very suspicious. But now you can simply run it through before it sends the email, generate a slight variation of the email, possibly even change the name, and the whole thing can be scripted up to just spit out all these phishing emails in a row. You can give it tone, right? You can give it certain urgency, like you can say like, this is incredibly important, you must do this right now. And the LLMs are very good at conveying this kind of like urgency and the fact that you have to get it done. We've also been experimenting with essentially having stuff do this in a semi-automatic way, so that if they reply to the LLM, you would send them a new message going, no, this is legit, I'm not an LLM, please click this exploit. So there is this like set whole thing up, but especially these things where why should they do it, right? Dear person, please do this, right? And you can definitely say, combining it with the list that we found before from the actual targeted people, feed that into the next step, and now it's just generated 100 unique phishing emails that all have some kind of, you could possibly even say like, well, this person is in IT, so they probably will have an email like this, but give me an email to the person in marketing about an upcoming event. And you can actually, script it up to be quite a very fast pipeline to phishing. This should go a lot quicker. And then, of course, I'm just talking about like the magic replying, right? Like setting up this, because one of the things that we've also found with phishing detection getting better and better is that you probably want to set something up based on a normal person's conversation back and forth. Most of the successful phishing we do nowadays is probably on the 5th or 6th back and forth email where you're convincing people. But that's a lot of work, right? Talking to people. So I'd much rather have the LLMs do all the talking for me while I'm in the pub or something, and then get them to actually do it. And then of course we're seeing a lot of the wishing via AI image and video and voice spoofing, right? So there's some people in our organization that have done a lot more than that than us, but it does seem like this is, if nothing else, is really freaking out a lot of the CISOs that we're working with, right? Getting their own voice talking back to them. And it definitely will be something that I think we'll be using a lot more. But having the whole ability to, in languages you don't speak very well yourself, right? We have a lot of European clients from countries where English isn't necessarily the normal language. If they start getting phishing email in their own language, there's also a higher chance of success in some cases. Sweden, Norway, from the ones that I work, if they get a phishing email in English, they're like, okay, suspicious. Norwegian, then suddenly it goes a lot better. And that you don't even have to learn Norwegian, right? So, well, the other stuff we talked about and they've seen everywhere is also the malware mangling, right? I think someone mentioned the other day, and it is very common to mangle some basic malware you get off the internet, like run that through an LLM and get it to be slightly different so it doesn't get signatured. Does the encryption in a slightly different way. You can just say, oh, give me a new encryption technique. No, not that one. Give me a more esoteric one. And it'll just come up with some malware. So you can quite often not ask them to say, hey, generate me ransomware, but you can say, generate me code that encrypts all the files and drops a message and changes the background image, and it'll happily do that, right? So you have to just kind of know what you want to ask for it. You can also add attribution, right? If there's someone you don't like, right? Make sure the malware looks like it's from them, and then they are the ones get picked up by the FBI and not you. But that's one of the common things, because also I have the exact same code just instantly generated in a different programming language. And then suddenly it will, again, look very different, it will behave very different. So malware isn't, most ransomware at least is not very complex software, right? So it's not like a huge innovation, but it definitely lowers the barrier of entry to who can come up with malware now, right? You don't have to necessarily even buy it off a black site, you can just get it from this. But yeah, same thing with functions, right? Read about a new esoteric encryption algorithm. Yeah, stick that in there, right? And you've got your own unique piece of malware. So I think the conclusion is just that blocking based on any kind of TTP or past action won't work, right? It'll have to be on the behavioral stuff. Most organizations are good at having that kind of setup, but we still see some running AV software where they're like, well, I've never seen this signature before, so it must be okay. I think I'll run this. So play with it if you want, but it's quite interesting how quickly it can generate some pretty effectively running encryption. It's not as good to write command and control software, but I'm sure it's getting there the cleverer these models get. So. Have phishing resistant MFA, right? If you're relying on people just being nice to other people, right? The LLMs can be very nice. So definitely need to have some good MFA. Application allow and listing, so you can't just execute random malware, is also good. And impersonation resistant procedures, right? I guess that's a difficult one, right? Because eventually, if you are nice enough to people, they will just give you their 2FA token as well, right? So at some point, it does become a little bit pointless in that sense. Your turn.
going to talk a little bit about escalating privileges, and the goal is basically to gain higher privileges within the organization, and we think that AI can help us with this because it is easy to process a large amount of data. So this is usually done after getting initial access. So assume we have access to some organization, then there are a lot of methods to do privilege escalation. Think about misconfiguration of things, but also exploits. And there are 3 things that we usually try at the first, after we get access to an organization. That's basically ADCS, so Active Directory Certificate Service, Kerberos roasting, and the third one, which is sort of almost inflexible for a lot of companies, is basically credentials in files. So let's look at the last one, because the first 2 are sort of easy to detect and easy to find and to exploit. But credentials in files is like basically a big data problem. So what are we after? What we basically are looking at is passwords in files, and these can be anywhere. So usually file shares, but it could also be files on SharePoint, Confluence, Jira, code repositories, all kind of stuff. And we have a couple of existing tools that we already use and where we can compare the results to. So among these are Snaffler, but also Nosy Parker and Trufflehawk are a couple of them that are used in pipelines, for example. So I made a model to basically process files. So what we basically want is a list of credentials. So I gave it a list of credentials, and a credential is basically a username, a password, and potentially a domain that we want to get. So, and what we have, we give basically a prompt to the LLM saying, given the following file, check if there are credentials in the file. And then we give some other instructions to get better results. And what we basically do, so we download files from file shares that might be interesting, and then we basically put it in a pipeline and ask the LLM, hey, is this file interesting? So we can alert the operator saying, hey, Gemini or Nosy Parker thought this file was good for you to look. And this makes sure that we can go through like thousands or hundreds of thousands of files potentially to get some credentials out. So I tried this on a data set of files from, that I found. And if you look at this, this is like, okay, there are a lot of numbers. So let me make a little bit clearer. So what do these results mean? So if a file has a credential and the tool says, yes, it has a credential, then it's a true positive, which is good. So look out for those. And then if a tool indicates no and it does have credentials, then it's a false positive, which is bad. And then for no credentials, you have a false positive if the tool says, yes, it has a credential. And it is a true negative if the tool says, no, there's no credential, and there actually is no credential. So there are 2 good things that we're looking for and the 2 bad things, basically. So if we add the nice things here, so you see that for true negative and false positive, it's best to have Trufflehawk. So it has the highest. So if Trufflehawk says there's a credential, then it's a very good chance that there's a credential. But if you look at the amount of false negatives that it has, so it didn't find a lot of credentials, basically. Whereas Gemini is not very good. Gemini is very eager to say, here's a credential in the file. So if you want more true positives, look at Gemini. If you want less false positives, then Trufflehawk is usually the best. And what we actually do in a pipeline now is basically run all these tools over it and then sort of rank them by whatever tool says yes. So if you have a hit from Trufflehawk, you should really look into that. And if you're getting a bit more desperate, then you look at the results that Gemini gives you. But still, it finds way more credentials than just Trufflehawk would give you. So this is actually a quite nice result that I found so far during our testing. So this is an example of a file credential. And this is quite hard to spot with other tools because it is, there's no really an indication that there is a credential. So Gemini correctly found this. So you see that net use is basically command in Windows, but the password is somewhere weirdly in there. So if you have net use with a /user and then there's another argument somewhere, that is the password. Gemini correctly deduced this, but other tools have a very hard time to figure this out. I'm not actually sure why Gemini knows how this works, but it's probably from some documentation of Microsoft. So it's kind of interesting that, that we can actually figure out these tools quite fast. I think this is
one of the other aspects that we think that Gemini will probably be better at in the future is you often find credentials in files that are essentially guides from one IT person to another, but they've done the whole thing via screenshots. If you do a grabbing over the file, it's not going to find anything, right? It's just screenshots, so it's nonsense to the text base. But most of the language models can read the pictures, or at least vaguely understand what it is. So we're also wondering if that will end up being unique there, that it can find interesting stuff from that. I guess in this case as well, just talking about some of the other lateral movement things, but because you have these large amount of data internally, like about how their estate is, you can also use the LLMs to kind of broke out, give me some information about the estate. Where is the oldest servers? Where is the stuff that always gets talked about in the old email files for lack of patch management or something? Or you can ask like the main information, right? Saying like, where's all the end of life boxes? Where's this sort of stuff? And of course, sometimes you can grab for this. You can grab for Windows versions. But it does go a lot faster with this because of the giant like context windows. It can pull information even faster than before. So, yeah. Yeah.
So how do you defend against this? Basically, you can run these tools yourself, which is usually the best way to actually do this. Like find all the credentials yourself, and then the other way around is if a lot of admins are putting credentials in scripts, then usually you have a different problem, namely that you don't have you're not using identity access management correctly, basically. So if you have the problem of a lot of credentials laying around the scripts or in Excel sheets or stuff like that, then it's usually best to look into using a nice password management system or an identity access management system where your scripts can get their credentials from some sort of vault and use that. That's usually a better way to actually fix your root cause. In the end, you still need some passwords. One of the major threshold or major annoyances for regular users is to have them to force them to change the password. And they usually just store their password after a while and some credentials in some text file somewhere. So usually this is an indication that you have a too strict password policy, basically. Okay, I'm gonna switch to internal recon, and our goal is to basically get higher privileges in the target environment and like find new targets to attack. And we hope that an LLM can actually aid us in this because we have quite a big of environments that we target. Most of you must be familiar with Bloodhound. This is the major tool that we use to actually go over networks. And it has two components. One, it has a gathering component, so you have quite a lot of tools where you can gather all the data from Active Directory. And then you have a tool that renders this. So you basically import the gathered data into a database, and you have the Bloodhound tool to do the analysis. In the end, this is basically pathfinding. So Bloodhound is the Google Maps of attackers in your network. So think of it as like a pathfinder. So if we think back, we had the workstation admin at chaos.local, and if we look in Bloodhound, we see that we have 30 first-degree local admins. So we have 30 systems that we can target. So where do we actually want to go? So usually we search manually to Bloodhound, or we just want to go to domain admins, for example, or a nice critical server. So we match them basically on an interesting feature like SCCM, WSUS, but also like maybe you can reach a domain controller already, stuff like that. So we have a high-value target. For example, we pick server 01 where we want to go, and we have a local administrator account workstation admin. So let's put this into Bloodhound, and unfortunately it says like no data returned from query, so there's no actual path. But the downside to Bloodhound and SharpHound is that it doesn't actually gather all the data there is. So it doesn't actually have all the, we call it edges, actually all the connections between all the nodes. So maybe we can use an LLM to sort of find the hidden connections, basically. So the connections that are there, but we cannot really access yet. So a lot of companies split up their user accounts. So you have an account for your workstation where you log in with, and your user where you get email from, for example. And then you have your administrator account that you use to admin a server. So you don't use your admin account for your email, basically. And in a lot of cases, domain administrator accounts are even more separate. But what if you know, what if you can combine all the user accounts for a single employee? So if you know the employee that is logged into the workstation eventually has access somehow to the domain admin, then it is still a good target to have. So what we're trying to do is locate one user and find out all the accounts that are basically belong to that user. So I made a model for this. So I just asked the LLM to give me like users with multiple accounts and then a list of accounts. And this is quite critical, reason why these accounts belong to this user. I noticed that if I didn't ask for a reason, it would just give me random things. But the moment you ask for a reason, suddenly the results improve dramatically. I have no idea why this is, but apparently this is the way LLMs work. So the prompt I used was, given the data, cluster accounts that belong to a single person, please specify a reason. And then some other stuff. I gave it some hints, like where it should look at, for example, similarities in the name, but also the description, that kind of stuff. So this is one of the results I got. This actually worked against a couple of clients already. And it says the display name for this user is admin account of Olivia Smith, which suggests this belongs to the same user, smith@chaos.local. And I've seen in quite a lot of companies that they didn't have very structured usernames. So sometimes they have admin Smith and then domain admin Smith and that kind of stuff, and user account Smith. But sometimes they have weird things and then they link it together somehow in the descriptions and stuff like that. And the LLM is really good at figuring this out. So the display name is Olivia Smith, and then the admin account says admin account of Olivia Smith. So we actually know, hey, these two accounts apparently belong together. And during my testing, I surprisingly get a lot of connections this way. So if we add the server, you see that admin Olivia is member of domain admins. So that would be a good target to actually go to. So if we know where Olivia is logged in, we can potentially figure out the admin password, and then we can go to server 01. So now that we have cluster users, we need to correlate the user to the workstation. So we can move to that workstation and then steal the credential. And this used to be easy because SharpHound was able to gather all session information as well. But nowadays that is Microsoft blocked this basically, so too bad. But let's try it with an LLM. So I have a correlation result. I basically asked the LLM, hey, can you maybe correlate these computers to users? And asked them also for a reason again. And I basically want a list. And I asked the LLM, given the two data sets, find a computer that correlates to a user, please specify a reason. And then I just uploaded to Gemini all the users and all the computers in one go, because it has a massive context window. So you just send everything at the same time, and good luck correlating all this stuff. In my case, it's based on real data, but I changed all the names. But the computer, laptop 1, has Ivy Payne listed in the description field. And for example, for laptop 3, it says the name listed in the description field. So it's quite likely that laptop 3 is actually owned by Olivia. So the user Smith must be linked to laptop 3, which is actually the case that they found in quite a lot of companies. So if we add edges to Bloodhound, for both Olivia, but also for the admin accounts that we found in the earlier step, then somehow we found a total path. Like without doing anything extra, we managed to correlate like our workstation admin and a path to server 01. So yeah, we have a path, we fished someone, we found a credential, we correlated the users, we correlated the users to the machines, and all of this with an LLM basically. Let's see. One side back. So we basically, yeah, that's how we managed to actually gain a lot of more access during a couple of assignments.
Yeah, and I mean, obviously Bloodhound being very useful, but sometimes if you're being a bit slower or a bit stealthy, or you can't get access to the Bloodhound data, or it doesn't exist because it's not, Windows-based, it could be a cloud-based stuff. The LLMs are still very good at reading things and identifying for you what you should know, right? And they can give it a few things, again, that Matthias is understanding. So network diagrams, make sure that you get all documents where a specific admin is mentioned, make sure that you get proxy information. large organizations that we kind of deal with over the sort of 20 odd years they might have been in existence has so much tech like garbage essentially lying around on their shares. But for that kind of garbage always contains like clues that if you read it manually, you wouldn't be able to put it together, right, that this is relevant. But if you stick it into the LLMs and ask them to say, correlate some of this information for me and give me some reasons, there is some unique things that it seems like be able to pick up. And I think someone mentioned this earlier, maybe in the neuroscience one, is because there's strange connections that you can't make between these two books in the random end, right? And think the same thing here, where it goes, well, these proxy settings were actually written by this particular person. I can see that in the metadata, which they did, 5 years ago, but then they eventually changed role into this, and then you should look at this file. So you can often find more information in internal recon than you would otherwise be able to get by simply reading or trying to use your own deductive reasoning. At least you could do it, but it would probably take you much longer than the average red team tends to last. And yeah, nothing's really like changed against here, right? The LLMs speed things up. They allow the attackers to make the connections faster and stuff, but there's still the same old principle of least privilege, making sure that you have the accounts split correctly, make sure you have network segmentation, make sure that everything actually is set up correctly, and don't reuse passwords and stuff like that, right? So still the same standard stuff, it's just that the speed has changed. For the completing the mission aspect, like the last part of our of the most red teams, right? When you get to the end and you want to figure out what can you actually do as the threat actor, what is it that you're supposed to emulate? Of course, that depends on the mission you've been given, right? Are you stealing sensitive information? Are you creating malware? Are you running like in like any kind of scam here? Or are you depending you guys to get a specific system? In all of these kind of cases, again, finding the thing you're looking for is what these things are very good at. So if you have like a large amount of emails that you've compromised and you say, I need to figure out where is this sensitive information I'm supposed to exfiltrate, you could try and use the search function in your favorite email client, but I don't know if most people probably agree that it's pretty terrible and it's not going to find the stuff, because in a lot of cases, you wouldn't also know what would constitute sensitive until you actually read it, and the LLMs can do that much faster for you. Likewise, some of the clients we work will say, well, I need something custom. I need to know that the ransomware groups can't run something completely new within my systems. And for us, then generating the custom ransomware in the last seconds is very easy to do. And this is what I was saying before, like it won't give you the malware that you need, but it will generate you code to encrypt files. Likewise, when we work with some of the banking stuff, there's probably going to be situations where they're asking us to understand how to connect to the switch network and steal $1 million. Don't know if anyone's read Swift documentation, but it's pretty long and pretty difficult to understand what the hell's going on. But asking the LLM to kind of translate these like 200-page PDFs into some simple steps, which did as a kind of a test. Not that I've been hacking any banks recently, but it was quite useful to actually say, because it correlated information from page 3 and page like 189 to actually tell you, oh, you need the 4 eyes principle, you need to bypass this some way. So even things where you just ask it to read for you is actually surprisingly effective. Likewise, we do a lot of like critical target lateral movement stuff, right? So can you get to the OT network, right? Even identifying where that might be is sometimes difficult for attackers because of the sort of how old a lot of these like power station networks or something is. Finding where the jump boxes are that are the easiest to get to can be an easy thing for the LLMs to kind of give you, given all the network information. Again, the massive like tech diagrams that you're working with, it can go through those for you and say, okay, well, it looks like because of the connections by this and this is actually the primary jump box into the, let's say, the production line or into the actual substation network. So yeah, and also because it doesn't really care the format of the data, right? Normally when we write tooling, we're hoping that everything's in JSON format or something so we can grab over it easily. But this could be written in Romanian and it would still like go, oh, well, this Romanian file over here and this document over here, that's actually mostly a hand drawing on a napkin. Those two things correlate, you should read that and then you can kind of use that for your next steps. Last defender's note, I guess, for us, one of the biggest things that we see clients not really spending enough time on is actually understand what the real crown jewels are. A lot of them seems to think that it's the CEO's email, which it might be, right? But that might be because the CEO would just get really angry and the real crown jewels of the network is your IP stored in this server somewhere, or it could be, the power grid. So trying to figure out what the crown jewels are is usually step one. And then we also get a lot of customers who want to stop ransomware after it runs, which is sort of a misunderstanding of how it works, right? So we always try to come up with them and say, look, you've got to make sure that you've stopped this way before they get to that position, and that goes back to some of all the other recommendations about defense and depth, right? So again, nothing like massively new, but there is an ability for the LLMs, at least as far as we can tell, for it to just accelerate and probably also lower the skill ceiling to some of these things, which isn't good for the defenders, right? It kind of expands the group of people that might be trying to make their money in the ransomware game. Yeah, list of all the things that we kind of like mentioned there. But I guess the real takeaways, yeah, AI can make things easier for the attackers, right? It's not a magic bullet, and I think we'll tell any client that asks that as well, right? It's not going to come and do the entire red team for you just because you ask it nicely. It's not going to understand what that means for the most part. But defense is mostly the same. Like, they're the same ruling, right? It's still defense and dev, it's still MFA, it's still segmentation and hardening and stuff like this. It's just the fact that the stuff that the attackers can probably do with this is that it will be covering. You can't rely on security through obscurity, right? Because it will troll through those 300,000 files in your network, right? Even if I can't do it, it can definitely do it. So I think that's where we kind of say that if it has changed the game a little bit, is that you can't, whatever hopes and wishes you were relying on before for security, is even worse now than they were before. And then we always say, like, use the same techniques that you would see the attackers use on your own networks, right? Run purple teams and red teams and use the emulation to figure out what would the threat actor do in my network before it actually happens. Is kind of like the only way to really know. Everything else, I guess, is just, again, speculation. Yeah, you want to do the conclusion?
Yeah, so what I mostly use AI for in red teaming is to process unstructured data into structured data that I can use then to attack the target, basically. Yeah, in the end, what can you do about this? Still, it's the same basic security principles. And an LLM might make it easier for them to attack you, but you still have the same tools at your disposal to basically prevent these things.
Yeah. And I think, like, you still get the hallucinations, right? So we sometimes do, as Matthijs showed before with the data as well, it will just often say, hey, this file is amazing. This is going to show you the path to the main admin. You're like, that's like a picture of a cat, right? It's just random sometimes, right? So as amusing as that is, it also can be like, it's definitely not like a silver bullet, right, in this case. But it does sometimes come up with some pretty interesting correlations that we don't think we would ever have been able to make ourselves, right? And I guess for the future, right, maybe LLMs have something to do in red teaming, but there's also some of the other aspects that we're kind of looking at, which is more about actual agent-based red team AI, where it will be much more sort of a
reinforcement learning.
Yeah, reinforcement learning-based agents that can kind of make decisions and move laterally by themselves within your networks, right? So when we get to that point, maybe next presentation we'll end up doing, I think that's going to be where there might be a slightly higher impact. The LLM's definitely a useful tool, but yeah, it's the future that's going to be a bit more complex and wild, I think. Yeah, that's it. Any questions? Oh.
A quick question as far as parameter size. I believe with Gemini, I think there's a couple of different model sizes that are offered. Did you all explore that all? Did you find any sort of correlations between like larger, smaller parameter size, making any of this more effective or maybe less effective?
Yeah, I tested mostly the credentials against multiple LLMs. I didn't see quite a huge difference in the results. So not really. For most of the last examples, it was mostly the case that you needed a huge context window, because then you can push all your data at once and it can do the correlations over everything at the same time. So I think I used one of the later Gemini models for that because it has like 2 million token window or something. And I couldn't test that with other models because then I had to split up the data and that was too difficult. So. Or too annoying.
What does a LLM attack look like from the defender's perspective versus, just a normal attack?
Yeah, I guess because we wouldn't be running it within the C2 itself, right? It would be running in the background, but it would still have to. You'd probably see a much larger data exfiltration amount, right? Because you'd have to get the data first. But to be honest, most of the things that we see, like detecting large-scale data exfiltration, never really seems to work for most of the clients, right? They'll be like, found out afterwards that 2 terabyte of data has left their network, right? So, but yeah, that would probably be the thing to look for, right? There's suddenly huge bursts of data disappearing off your network, and you'd be like, oh, that was weird. And then that's because it might be correlated. But like even something like Bloodhound, which seems large to us when we have to try and exfiltrate it, is like still like hundreds of megabytes maybe, right? So that in the noise of a normal organization, I'd say very difficult to detect. Yeah.
The bigger impact you might see is that it has like a really weird correlation that you never could have done yourself, like that it correlated a couple of different things together. That in earlier red teams you wouldn't have done that because a human would never have correlated that. So you might get really weird correlations that you've not done before. But most of these things I've shown you, you can do manually anyway. It just takes a lot of time. So it's more or less the speed aspect as well as the massive amount of data that we usually collect as well.
Yeah, yeah, thanks.
Thanks. Did you consider the forensic side of the LLM? So if you were trying to cover your tracks as an attacker and you were able to like cover your OPSEC for the prompt itself, is there anything within the LLM that you would use to scrub your activities, or for the other side, the forensic investigator to track what was produced?
Yeah, so I mean, one of the things that we mentioned around, especially if it comes to, obfuscating your malware, is the fact that you can add randomness to it and stuff, right? That wastes the time of any forensic investigator. But if you're talking about the actual queries to the LLM, I think for a company to find that, most of what you would do if you're a real cyber criminal is you'd definitely run it as a local model, so that unless they get access to your box down the line in the investigation, they would never know what you were up to, and you'd probably wipe your box fairly often. But fortunately, cyber criminals do make a lot of mistakes, right? So we'll see them just querying straight up to ChatGPT. So I did see a presentation by one of them once, and he was saying that they were trying to obfuscate it by essentially asking roundabout questions to try and hide from that. But it becomes very difficult. Ironically, you almost need an LLM to ask which of these queries are bad, because they're fairly innocuous. Like when I ask it to, hey, can you just drop in loads of reference to my friend David in all this malware code, and then produce some code that will jump from box to box, right? So then it's very difficult for a human to see that query and go, oh, this is definitely malicious, especially in a large enough amount of data, right? So I think for our case, in terms of obfuscation and protection, we'd probably just use it for making sure that every time a new machine was moved to, it would be a slightly different variation of the malware, so that even when you try to forensically analyze it, you would have to do it on all of them to make sure that you were actually dealing with the same thing. So yeah, just making life terrible for any of the reverse engineers, basically.
Yeah, to add to that, so because we're part of Google, and Google's LLM, we can basically have unfettered access that way. And Google will first ask us, like, what are you doing, before they actually cut us off. So we don't really have to hide from Google itself, which is a nice point to have. For another thing, the LLMs can easily, like, if you give it a set of, for example, service names, it can easily give you legit looking ones that look really like that. It's called masquerading. So you basically give it existing services and say like, hey, can you give one that looks very much like this with a description and everything? And that really helps with staying under the radar. Because if the system admin sees like another Citrix service and then with a nice looking description, they are more likely to ignore it. So LLMs have with lots of use cases for these type of things, but we can use an LLM to basically masquerade into the network. So give it like legit looking descriptions and
metadata and all that.
Metadata and stuff like that. You can exfiltrate data and then use an LLM to basically blend in.
Also means you don't match any previously known TTP exactly. So correlating who's doing it becomes more difficult as well. I'll be running out of time, I think. Yeah.
To that point, do you see a potential usage of LLMs, querying LLMs for obfuscation?
Yeah, definitely. I think that's going to be like where we're going to end up eventually. It's like when you get the LLM chatbots chatting to each other now. Yeah, it's going to be the same, but there's going to be a guy on defense using LLMs to try and find all my files, and there's going to be me on the other side making files weirder and weirder, and eventually, I don't know what's going to happen. Singularity, maybe? Yeah.
So nice LLM injection to inject into the attacker one and back. Yeah, it's going to be great.
Infinite circle.
Yeah, it will be nice.
Yep. Cool. Thanks, everyone.